All right, welcome to our third right triangle trigonometry review video. In this video, we are going to apply our special right triangles to the unit circle. All right, let's look at how we can use our special right triangles to come up with some of our trig values here on our unit circle. So we have our degrees marked on our unit circle, 30, 45, 60, 90, etc. And we have our review information, the Pythagorean theorem, our definitions for sine, cosine, and tangent that we developed using right triangles. And then we have our special right triangles here, our isosceles right triangle, and our 30, 60, 90 right triangle. So if we consider first here where we have a 30-degree angle, and we draw our right triangle as such, we know that the sine of 30 is going to equal the opposite side, which we know from our right triangle is 1/2, over the hypotenuse, which since our unit circle is defined to have a radius equal to 1, matches the special right triangles we have here over 1, which is just 1/2. That is also our vertical distance here, and therefore our y coordinate for this point here. And if I want to find my x coordinate, then I would consider cosine of 30, which I know from my definition is the adjacent side, which is going to be the square root of 3 over 2, over the hypotenuse, which once again is just 1, so that's the square root of 3 over 2. Well, that is our horizontal distance here. Since this is at the origin right here, then that gives us this distance, or the x-coordinate for our point here, formed by the ray with a 30-degree angle. So the coordinates of our point here are the square root of 3 over 2. If I grab a different color, then I can look also at my 45-degree angle, building the triangle here, and now I'm considering a 45-degree angle. Our radius is still 1, which is the hypotenuse of the isosceles triangle we have here. Sine 45, per our definition, is the square root of 2 over the hypotenuse, which is still 1. So that's going to be the square root of 2 over 2, which once again is our vertical height. And cosine of 45 is going to be the adjacent side, this side right here, over the hypotenuse, which again is 1, so the square root of 2 over 2, and those will be the coordinates of this point here. Now if I look at the 60-degree angle, I have a 60-degree angle right here. In fact, let's grab a different color for it. I have a 60-degree angle right here. So if I look at my 60-degree angle, the triangle I form here, then I am considering the sine of 60 to find the vertical height. Because if I rotate this, then I'd be looking at this triangle. And the sine of 60, the side opposite the 60-degree angle, is the square root of 3 over 2. And the cosine of 60, the adjacent over the hypotenuse, when our hypotenuse is 1, is going to be 1/2. So this point here is going to be 1/2 square root of 3 over 2. So as we extend our definitions of sine and cosine to use these reference angles as we go the rest of the way around our unit circle in the next lesson, then I am able to find the sine and cosine values using these special right triangles for all of the angles that are listed in red or blue on my unit circle. And then I can consider a unit circle definition that we've developed by using these special right triangles to find the cosine and cosine values for these purple angles. So in our next lesson, we extend the sine and cosine using these special right triangles to the rest of these red and blue angles.